Hi, this is Gunasekaran, Assistant Professor of Mechanical at SNS Institutions. Okay, now we are seeing about introduction to rigid bodies. Okay, first of all, strength of material. In the strength of material, it is ability to withstand and apply load without failure or plastic deformation. The field of strength of materials deals with forces and deformation that result from their acting on a material. Okay, rigid bodies. In strength of material, rigid bodies is a theoretical construct representative on object that remains under external forces. It simplifies analysis by eliminating considerations of deformations. Okay, allowing engineers to focus on static equilibrium. This facilitates to deformation of reaction, internal forces, and moments within the structural, such as stresses and frames. While useful for basic analysis and understanding of structural behavior, it is an withstand limitation. Okay, real world material, example, deform to some degrees. So while rigid body assumptions can provide insights, they may not accurately represent the behavior of complex system occurring constructions of flexibility and material properties of precise analysis. Okay. Rigid bodies in mechanisms are objects that maintain shape and size under applied forces. They simplify analysis by deformation, allowing focus on static equilibrium. Rigid bodies exhibit behavior, they transmit forces and movement without internal deformation. Analysis often involves determining reaction at supports and internal forces in member. Okay. While useful for static and basic structural analysis, rigid body assumptions having limitations. Real world material deform and complex system require consideration of elasticity. Okay. Rigid body concepts provide valuing insights into structural behavior and form of foundation for understanding more mechanical systems. Okay. Crystal strain analysis for rigid body. Okay. It is simplified due to their assumption inability to deform. In such analysis, stress the internal forces per unit area, remaining constant throughout the body, allowing straightforward deformation of reaction forces and moments. Okay. Strain the measures of deformation is simplifying calculation and enabling direct assessment of structural stability. Rigid body provide a foundational framework for understanding mechanics and particular in static and structural analysis. However, it is crucial to recognize that idealized natural real world materials exhibit deform under load. More complex analysis techniques for structural assessment of stress and distribution in flexible structures. That means bending stress. Rigid body experience various stress levels in across different sections impact their structural integrity. Okay, torsional load is nothing but torsional force induced shear stress within rigid body. Okay, so that within rigid body affect their resistance to twisting. keynotes. 3D, that means dimensional analysis and Young's models, Newton's self-science law. Understanding the behavior material under different loads within the elastic limits and the structural reliability. Thank you.